present chapter is the differential equations chapter. Already introduction is completed. Then how to find the order and the degree of the differential equation is also completed. Well, enter into next lecture. Yesterday one student asked me, sir, what is the value integral 0 to x step x dx, where x is any real number. X is a real number. X is a real number, and what is the value integral 0 to x step x dx. So first we will discuss this example. Then again we will continue our chapter differential equations. So integral 0 to x step x dx, where x is any real number. So first of all, if we take x is a real number, I can write x is equals to I plus f, where I is the integral part of the x, integral part of x, and f is the fractional part. F is the fractional part. Since this is the real number they given, so real number means integral part will be there and the fractional part will be there. So I can consider x value as I plus f, where I is the integral part of x and f is the fraction part. I can take like this. Now here our aim is to find the value integral 0 to x step x dx. Integral 0 to x step x dx. So I can split this integral value as integral 0 to 1 step x dx plus integral 1 to 2 step x dx. By continuing this process, integral I minus 1 to I step x dx plus integral I to I plus f. I plus f means nothing but x step x dx. Since here x is equal, these are I plus f. So I can split the, whenever this step x function is there, step x function is, that is the discontinuous function, that to integer to integer. I can split the total integral value like this. Now if I simplify this value, integral 0 to 1 step x. So as x belongs to 0 to 1, what is the step x value will be 0. So first value will be, here it is 0, plus second value, as x belongs to 1 to 2, step x value equals to 1. So this value I can write 1 to 2, 1 into dx. Now next value, integral 2 to 3. As x belongs to 2 to 3, what is the step x value will be 2. So here you will get 2 dx plus integral 3 to 4, I can get 3 dx. By proceeding like this, what about this value? As x belongs to I minus 1 to I, the step x value is equals to I minus 1. So here I can get integral I minus 1 to I, here it is the value, I minus 1 dx is the value, plus last value, integral I to x. Since I is the integer value, so this value changes to integral I to x, here it is the value, I into dx is the value. So basing on the step x, I split the integral values like this. After that, as step x value, take the value between 1 to 2, 2 to 3, I split like this. Then I can simplify this value, which is equals to 1 to 2 integral dx. What is the value will be x under the limitations 1 to 2, plus next value 2 into integral dx value x between the limitations 2 to 3. Next value 3 into integral dx value x between the limitations 3 to 4, plus by continuing this process, I can get, here it is the value I minus 1 into x, integral dx means x is the value, between limitations I minus 1 to I is the value, last value plus I into integral dx means x is the value, so x between limitations I to x is the value. Now simplify this whole value, which is equals to, here if you observe, upper limit value minus lower limit value. You can get 2 minus 1 means 1 is the value plus 2 into 3 minus 2 means here it is the value 2 plus next value 3. By proceeding like this, here you will get the value I minus 1 till here plus what is the next value will be I into here if you apply upper limit value x minus I. This is the value you can get. Now if you observe till here 1 plus 2 plus 3 plus up to so on I minus 1. This is the formula basing on sigma n. What is the formula for sigma n? N into n plus 1 by 2 is the value. So this value sigma n means n into n plus 1 by 2. Basing on this, here you will get the value. I will write here. That implies integral 0 to x step x dx, which is equal to sigma I minus 1. What is the formula sigma n formula? N into n plus 1 by 2. So here you will get I minus 1 into I minus 1 plus 1 means I by 2. This is the value plus what is the next value will be I into x minus I is the value. But here answer should be in terms of x only. Here I is the variable we assign. What is I value here? I is equals to integral part of x. So here I can take I as the integral part of x. Means indirectly here I can write I is equals to can I write like this now? Step of x. Since I is the integral part of x, so I can write I value as step x. So by replacing this value here I can get step x minus 1 into step x is the value whole by 2 plus I. Again I means what is the value? Step x into here it is the value x minus I means again step x is the value. If I simplify this whole value, we can get the answer. So here the thing is, whenever x is a real number, the key step is this one. X is equals to I plus f, where I is the integral part of x and f is the fraction part. Then whenever this step x function is given, you know how to simplify that value. Okay, go through this one example. One more example I will explain. Here the example is, find the area of the region bounded by, this is the example they given, 4 less than or equal to x square plus y square less than or equal to 2 into mod x plus mod y. What is the area of the region bounded by 4 less than or equal to x square plus y square less than or equal to 2 into mod x plus mod y. What is the area of the region bounded by these curves? Now listen. First of all here, this is one curve, this is the second curve. If you observe this one here, from these first two values, this value, what I can get here, bring this 4 value this one, then I can get x square plus y square minus 4 greater than or equal to 0. What this equation represents? This is the equation represents the circle whose center is at the origin and the radius of the circle is given by the 2 units. Next, here mod x, mod y they given. So whenever mod x, mod y is given, then we have to discuss the different cases. When x value positive, what is mod x? When y value positive, what is mod y? When both are negative, one is negative, one is positive. Different cases will come. First, I can consider here it is the case if both are positive. If x comma y both are positive values, Then what about the equation changes to x square plus y square less than or equal to 2 into x plus y. Since if x is positive, automatically what is mod x value I can take x only. When y value also positive, directly mod y I can take as the y. Then if you observe this value, here you can get x square plus y square minus 2x minus 2y less than or equal to 0. Of course, this is also a circle with the center. What is the center for the circle? Center is equals to 1 comma 1 and the radius of the circle is given by root of g square plus f square minus c. You can get root 2 is the value. Now I can plot graph of this circle and graph of this circle also. Then exactly I can get one rough idea where we have to find the area of the region. So I can take the coordinate system 0, 1, 2, 3. Let this is the x-axis. This side value minus 1, minus 2. And here it is the value 1, 2. And this is the y-axis. Minus 1, minus 2 is the value. This is the circle equation. X square plus y square greater than or equal to 4 means for the circle exterior region we have to take. The two radius is equal to units. The circle will be, you can get, let this is the circle. This is the circle. X square plus y square equals to 4. That two is x square plus y square minus 4 greater than or equal to 0 means exterior of the circle. Next, for this one, center is 1 comma 1. So let this is the center 1 comma 1. This is the center. Radius is equal to root 2. Okay. Radius is equal to root 2 means this distance is nothing but root 2 only. This is the distance root 2. So obviously this circle there is no constant passing through the origin. If you construct that to here, this is the point 2 comma 0. Is the 2 comma 0 lies on the circle or not? Cross check one time. 2 comma 0 means 2 square 4 minus 2 into 2 4, 4 minus 4 0. So the diagram of for this circle is given by, you can get the second circle is, you can get like this with root 2 radius. This is the circle you can get. That to here for this circle they are given less than or equal to 0. Less than or equal to 0 means interior. For the first circle exterior, second circle interior means you will get the region is here. So this is the region we have to find. And that too here, this area, not only this area, here we can consider only one case. Both are the positive case. X value positive, y value positive. Due to that reason, here I am getting in the first quadrant. If you construct the next case, x less than 0, y positive. Here one more circle. If both are negative, here one more circle. If x is positive and negative, here one more circle. So first calculate this region area, then multiply with the 4, you can get the total region area. So how you can get this region area? That too here. For the second circle means for this circle, this is nothing but the diameter. This is nothing but the diameter. So obviously, what about the area of this whole region? The area of the whole region is given by semicircle area. What is the semicircle area? Of course, area of the circle is given by pi r square. So here semicircle means pi r square by 2. Then pi r square by means pi into r value is root 2. Root 2 whole square by 2. Then you will get the value pi. Here root 2 means 2 will get cancelled like this. Then this whole region we got it. Then we have to delete this region area. How you can find this region area? Again, this whole part, if you observe. Next here, if you observe here, this is the fourth part of the circle. What about this region area equals to pi r square by 4, and this region area how you can get it? From the total this quarter of this circle, you have to subtract this region area, then you will get this region area. What about this region area? This is a right angle triangle. So this right angle triangle means minus half into base into height. What is the base value? 2 units. Height value 2 units. Then base into height. This is the value. So if you simplify this value, 4 get cancel, which is equals to pi minus 2. I got this region area is equal to pi minus 2. Therefore, the shaded region area, shaded region area equals to, here I can get from this pi, I can subtract pi minus 2. Then I can get which is equals to 2. Therefore, the required area is equals to. So here I am calculating in the first quadrant, I am getting this 2 square units. Similarly, second quadrant, third quadrant, fourth quadrant. Totally required area is given by 4 times of 2, which is equals to 8 square units. Okay. Next, one important point here, like in the classroom notebook, how we are preparing your classroom notebook, like that only exactly you have to prepare your classroom notebook. Why? Because physics lectures also coming and chemistry lectures also coming, mathematics lectures also coming. So if you prepare notebook, that will be more helpful to you. So compulsory all of you prepare like a classroom notebook, 100%. That is very advantageous for you. After that, for example, integration long back completed. Whenever if you want to revise the integration, maybe you can't identify the videos also. Why? Because long back it is completed. So best thing is prepare the classroom notebook. By preparing the classroom notebook, it is very helpful to you. Okay. Now present chapter, differential equations. In differential equations, already I given what is the order of the differential equation. Second part, what is the degree of the differential equation and how you can find order and degree of the differential equations. It is already over. Now today the extension part. Okay. We will discuss here formation of differential equation. Today we will discuss formation of differential equation. How you can form the differential equation. If one equation is given, from that equation, how you can form the differential equation. We are entering into this in detail. Consider the equation y is equals to mx. Y equal mx means what this equation represents. This equation represents family of the straight lines. Family of straight lines which are passing through the origin. Why I am mentioning this family of straight lines means here m is the parameter. M is the parameter. If m equal to 1, that is one line. If m equal to 2, second line. M equal to 3, third line. Means by varying this m value, I can get infinitely many number of lines which have the common property passing through the origin. Due to that reason, these are the family of the straight lines which are passing through the origin. Means 0, 0. Now, for this equation, if I differentiate with respect to x, then here what I can get, dy by dx is equals to m is the value. Let this is equation number 1. So here m value I got dy by dx value. Replace this m value in equation number 1. Then what I can get, tell me, y is equals to m value I got dy by dx into x. If I simplify this value, I can get dy by dx equal to y by x. This is the differential equation. This is the differential equation. And here, what the method we are using? This method is known as the formation of the differential equations. So here few steps are there for formation of the differential equation. First, in the given equation, they will give one equation, or sometimes from the bit itself only we have to form the equation. So in the given equation, how many parameters are there? First we have to cross check that point. First point is how many parameters are there? How many parameters? This is the first point. For example, in this equation, only one parameter is there. So one parameter is there means one time only we have to differentiate. After differentiation, we have to eliminate that parameter, then you will get the differential equation. So here, in order to form a differential equation, the first step is how many parameters are there. After finding the number of parameters, that much number of times, differentiate the given equation. Differentiate given equation. This is the next step. In this example only, one parameter is there. I differentiate one time. So I can get this the equation. After differentiation, I am eliminating the parameter. So here also that much number of times differentiate the given equation. After differentiation, eliminate the parameters. Eliminate the parameters. Obviously, if you eliminate those parameters, you will get the differential equation. This is the formation of the differential equation. This is the important steps. First, they will give one equation. In that equation, how many parameters are there? First step is that one. How many parameters are there? After observing those parameters, you have to differentiate that much number of times. That much number means if the given equation contains one parameter, one time you have to differentiate. If it contains two parameters, two times you have to differentiate. Of course, in this example what I given, one parameter is there, I differentiate one time. So that much number of times we have to differentiate the given equation. From the differentiation and from the given equation, you have to eliminate the parameters. Then you will get the differential equation. These are the steps involving the formation of the differential equation. Now listen in detail. So here y is equal to mx equation. For this y equal to mx, the corresponding differential equation is given by dy by dx is equals to y by x. And here one more important point. For this differential equation, this is known as the solution of the differential equation. Solution of the differential equation. This is also one more important point. For this differential equation, this y equal to mx is known as the solution of the differential equation. Now I will define what is the solution of the differential equation. Solution of the differential equation means, here what we call y in the beginning of the class only I given. Y is the dependent variable and x is the independent variable. So here a solution of the differential equation means it is a relation between the dependent and independent variables involving some arbitrary constants, which is known as the solution of the differential equation. Once again, for this example, dy by dx equal to y by x I got. From which equation I got? Y is equal to mx. So here, for this differential equation, y is equal to mx is called the solution of the differential equation. If you observe in this solution, this y is the dependent variable, x is the independent variable. So solution means, how we can define the solution of differential equation means, a solution of the differential equation means it is a relation between the dependent and independent variables involving some arbitrary constants. And here solution of differential equation is classified into two categories. One is the general solution. and the second one is the particular solution, and this is known as the particular solution. Particular solution. What is the meaning for the general solution and what is the meaning for the particular solution? So general solution means simply they will give one arbitrary values like this. For example, here instead of m I can fix that m value. Here m is given. Instead of m I can give m is equal to some one particular value to arbitrary constants. If I assign a particular value in this solution, that is known as the particular solution. So first of all, solution means it is a relation between the dependent, independent variables involving some arbitrary constants. That is known as the general solution. If in this general solution, for these arbitrary constants or parameters, if I assign a particular numerical value, then that is known as the particular solution. So in this entire lecture, first we form the differential equation. From this differential equation, we derive the solution, and we given the what is the definition of the solution of differential equation. After that, again in the solution also there are two categories. What is the general solution? What is the particular solution? So general solution means it involving the arbitrary constants, but particular solution means for the constant values, means for parameter values. If you assign a particular numerical values, that is known as the particular solution. Okay. Now in the continuation class, first we will discuss about the formation of the differential equation. This is the our next class, formation of the differential equation. After that, solving the differential equation means how to find the solution of the differential equation. In the next class we will discuss. So first of all, today we will discuss about the formation of differential equation. Once again I will explain how you can form the differential equation. From the given equation, the first step is observe how many parameters are there. After finding the number of parameters, that much number of times you have to differentiate the given equation. After differentiation, you will get few more equations. From the given equation, after differentiation equations, you have to eliminate the parameters. By eliminating those parameters, you will get the differential equation. One more example I will give. For example, if they given form the differential equation for y is equals to a into e power x plus b into e power minus x. If they given like this, form the differential equation corresponding to the curve y is equals to a into e power x plus b into e power minus x, where they will mention a comma b are parameters. A comma b are parameters. So here this is one parameter, this is the second parameter. So here the important thing is, first step is, in order to form the differential equation, how many parameters are there? How many parameters are there here? Two parameters are there. So first you have to get one idea. So two parameters are there, compulsory we have to differentiate two times. So here first differentiate y dash. Y dash means nothing but dy by dx. Remember that one. Y dash equal to a into e power x derivative e power x plus b into e power minus x value e power minus x into delta minus x value minus here you will get. One time derivation completed. One more time we have to run. Second time also differentiate. Again by differentiating. What I can get here is value y double dash equals to. If I differentiate second time, then y double dash equals to a into again here e power x. Here if I differentiate, I can get plus b into e power minus x. That implies y double dash equal to. What is this whole value? This whole value nothing but y only. So y double dash is equals to y. So means y double dash means d square y by dx square minus y is equal to 0. This is the differential equation corresponding to the given curve equation. Y is equals to a into e power x plus b into e power minus x. So for this given curve equation, this is the corresponding differential equation. And for this differential equation, what we call this one? This is nothing but solution of the differential equation. Solution of the differential equation. And that too, if you observe here, d square by dx square minus y equal to 0. Is there any arbitrary constants? No. That means here we are deleting the parameters. By deleting the parameters, how you are deleting the parameters? With the help of the differentiation. So by 2 times differentiation, we are deleting the values a comma b, nothing but parameters. Then you will get one differential equation. This is the formation of the differential equation. Okay, thank you.